Hi folks, we're going to take a look at page 209, number 15. So let's take a look at the question. So they give us the diameter of the moon, and they tell us the orbital radius of the moon of 384,400, and they're telling us that this is from the center of the Earth. And what we're doing here is we're observing the moon from the surface of the Earth, and they want to know what angle is subtended by the diameter of the moon. Okay, so I think the best way to try to understand this problem is to draw a diagram. So give me a second. I've got a diagram here ready to go. And you're going to see that I've added a bit of information, okay? Because what we have here is we have the moon. They give us the diameter of the moon here. And what they give us is they give us the distance to the center of the Earth, which is 384,400 kilometers, but they're telling us to calculate the angle subtended from somebody on the surface of the Earth. So what I did is I looked up the radius of the Earth, which was 6378. So the actual distance that I have here, okay, the radius, if I'm looking from the surface of the Earth, is 378,022 kilometers. Now, I'm going to actually show that whether I use this number or that number, relative to the diameter of the moon, they're very, very similar. We're going to see that we're going to get extremely similar answers. So I suspect the book expected us to just take this number as an approximation for the distance from the surface of the Earth to the moon. The distance is so far that this extra 6378 kilometers, as big as that is, doesn't make a big difference when we're comparing to the distance to the moon. All right. So the question is, how are we going to solve this problem? Well, if we think about how we talked about that arc length formula, we know that if I have the radius of a circle, okay, and in this case here, I don't have the angle, but I'm looking for this angle, okay, it's going to be subtended by an arc length of this circle. So technically, the arc length would be, part of some circle, okay, that has this given radius here. So if I use the arc length formula, what I'm really finding is this arc, okay, which is part of the circle. But the idea here is that the moon is so far away that the measure of this arc should be very close to this diameter of the moon. So we're going to use that as an approximation, okay? So technically, the diameter is a straight line, and the arc in the arc length formula is this sort of curved piece of a circle, okay? But because the moon is so far away, these two things really are going to be very close to each other. So that's why we can use it as a good approximation. All right. So if I want to find this arc length, okay, which is going to be approximated by the diameter of the Earth, I know that the arc length, A, is equal to r theta. Okay, and in this case here, I'm looking for theta. So theta is equal to A over r. Now that's approximately equal to, so this arc length is approximately equal to 3480. Okay, and if I divide that by this radius as given to the surface of the Earth, 378,022, I'm going to get the angle in radians. So let's calculate that. 3480 divided by 378,022, and we get about 0.0092. Okay? Now, let's just say we didn't bother looking up the radius of the Earth, and we just use 384,400. We're going to see that we're going to get a very similar answer. So if I took here again, this arc length is being approximated by the diameter of the moon because it's so far away, so much smaller than this distance. Okay, and I divide it instead by 384,400. Let's see what we get. I suspect it's going to be pretty close to our original answer, 3480 divided by 384,400, and we see that we get something very, very close, 0.0091. Okay, so had we worked with this approximation for the distance, we would have gotten 0.0091 radians, or if we took the more precise answer by looking for the radius of the Earth to compensate for the distance being on the surface as opposed to from the center, 0.0092. Very, very close. All right. So now they also wanted this answer in degrees. Okay, so I'm going to do this in two ways. So one way is to use our, proportion, is to say pi radians is the same as 180 degrees. All right, and we have the angle in radians. Okay, and we want to determine how many degrees. So I can do this by just cross multiplying. So 180 times 0.0092 and then divided by pi. Okay, so let's calculate that here. So we have 180 times 0.0092 divided by pi, and that's equal to about 0.53. So again, a very, very small angle. Okay, so despite the fact that we're talking about this diameter, which is a huge distance, 3,480 kilometers, it's so far away from the Earth that the angle that's produced by that diameter is exceptionally small. Okay, so very often when you are talking about angles looking at very distant objects, you're very often talking about very small angles, okay? Which is why even when you're dealing with radians, instead of dealing with radians, you might be breaking down radians into smaller units. So you might be using milliradians, okay? Or with degrees, we talked about using minutes and seconds as smaller units for measuring those angles, okay? So again, let's recap. So step number one was to set up our diagram and to realize that while this diameter was not part of the arc of a circle, it would be very close. It would be a very close approximation given the distance from the Earth. And then from there, it was just a matter of using our arc length formula. Okay, that's it for this one.